Hello, this is Stephanie Washer from RVC. This video is over Module 2, 1B cabling from the PCT 110 Network Essentials course using Cengage Mindtap. So we're going to go over that. And so we're in 2.1b, types of cabling. So we're going to talk about patch cabling, which is like the short distance cabling that goes from the workstation to the data jack. You know, for example, at your own house, you'll go from, if you don't have everything hooked up wirelessly, you might have a workstation that is plugged into your router, and that's going to be a relatively short cabling. So that's a patch cable. Anything that has two ends, a connector at both ends, that's going to be a patch cable. You can go get them at Menards or order them online. And then there's horizontal cabling. So we go from the workstation to the wall, and then we go from the wall to the data center. So that is called the horizontal cabling. And that is, we don't really know how many feet that is, but usually generally it's under 90 meters. Because the ANSI TIA standards, we can only go 100 meters for horizontal cabling. So we can only go with UTP and STP, we can only have a max amount of 100 meters. So we have to think about this. So we want less than 90 meters for horizontal cabling, and we want less than 10 meters for the workstation or the patch cabling. And I know they said the maximum allowable distance for horizontal cabling is 100 meters, but you have to include that workstation in on it. So that's why you figure 90 meters of horizontal cabling and then the 10 meters for your patch cabling. So it's got to be from the workstation to the switch, because the switch is what matters. Workstation to the switch, that's the one that matters, or router, depending. So max 100 meters or 300 foot. Then we've got, so here's what you have really, here's a kind of like a behind the scenes picture. We've got our PC to the wall, and then we go from the wall to our patch panel and then our switch. So we've got to think about all of that. Once it makes it to the switch, 100 meters is all you need to get to the switch, 300 foot, and then everything, it goes out to the IDF or wherever it needs to go from there. So 100 meters from this PC to the switch. So any PC or IP phone, voice over IP phone or printer or anything that's connected to the internet with a cable needs to be no more than 300 feet distance using UTP or STP. So that's what we've got here. Then we have the definitions of UTP, which is unshielded twisted pair and shielded twisted pair. So the ANSI TIA standards are the ones that say can't go over 100 foot when you're using UTP and STP. And that's all copper-based cabling. So it's going to send all the info that it needs in electrical current. So it's going to use that copper for the electrical current. And then I'm going to show you the difference between UTP and STP. But we also have fiber optic cable that you can use, and that's glass or plastic. And we've got single mode fiber and multi-mode fiber, and those are light. It uses light to transmit the information. So we've got LEDs on it or lasers. So we've got copper-based, which is UTP. STP uses electrical signals. Fiber optic cable, two examples are single mode fiber, multi-mode fiber, and that uses light, which is, sent via laser or LED. So here's our two examples of UTP. We've got unshielded twisted pair, and you can see that it doesn't have any, it's just 4 cables in here that are twisted together. They're color coded. And then we've got the STP that has the extra shielding around the outside. These are nice if you want to protect it, but it does get annoying when you're trying to do things by hand. Then we've got backbone cabling, which goes from, and I think we had a picture up here. So here's our backbone cabling going from the switch or router from the IDF to the MDF. So it'll connect to buildings, connect to IDFs, wherever it needs to go. And you'll have conduit run. So we've got conduit here, we've got conduit there that runs from building to building. You want to make sure it's rodent You just want to make sure that it's properly protected from the elements and from rodents. So you don't want to have any physical damage. I had my husband and I ran cabling for a friend of ours, and we ran the cable, and it was winter. It was like January. It was cold. And we just ran it from his sheep barn to his house so that he could have a video set up so that he can check on his sheep. And if it was freezing in the middle of the night, he didn't have to get up and go outside and go see the sheep. He could see them all nice and warm and cuddled in the barn, but he could tell if they were in labor, and if they were in labor and having their lambs, he would have to go out and tend to them. So if he didn't have to go tend to them, and if they were okay, via video, he would just stay in his bed, right? So we ran the cable. It was January. It was so cold. And we just ran it over the grass into his house. Well, he called us, I think it was the next year. He called us the next year, and he's like, I can't view the videos this year. Well, he had unplugged it because he didn't need it all summer, so he had unplugged it, but when he plugged it back in, his dog chewed right through the cabling, so we had to replace it. So you just want to make sure it's protected from any kind of damage. It was kind of cute because the dog looked so guilty, and it was perfectly matched his teeth. Cable management. So different cable management, you want to make sure everything's terminated properly. And so with twisted pair cabling, you don't want to leave, it says more than an inch of exposed cable. You just want to make sure you leave as little as possible, because the more cable that is shown, the more you might have interference on it. And crosstalk is one of those items that can cause issues. So crosstalk, and when you click on any of these words, crosstalk is just a nearby wire can cause issues and interfere with another signal of the pairs. So you just want to make sure. Yeah, and then that's another, the termination is important for that. And then the twisting. The twisting is part of the item that helps that crosstalk. So if you untwist it and then terminate it, and you have more than an inch or so untwisted, that's going to be a problem. And then the bending radius. So depending on your cable, you want to make sure that you don't bend it too far. So twisted pair can bend pretty far, but you don't want to have it, crimped in half. You don't want to do that. You just want to be careful. You just want to be as careful as possible with it. And looping it is a good way to do it. You want to loop it, but not smash it so that it has a crimp. So it's totally smashed and crimped. You just want to make sure, kind of like a hose. So when you're running water to your garden, or you've got a hose that you're watering plants or whatever, you don't want that crimped to the point where you can't get water out of it. So think of it that way. You don't want it crimped because that crimping could cause issues, and you might not get information or data out of it. Continuity, you just want to make sure each segment is transmitting reliably. So you can look for some, in long stretches of cable, there could be some errors that happen. Loosely cinched cables, that you want to make sure you do that. If you cinch them so tight that they're squeezed, it could cause issues. It could lead to any type of issue. And when it's squeezed too tightly, I know you want to keep it up and keep it nice, but you don't want to squeeze it too tightly and cause problems or rubbing or breaking any of that outer covering. Cable coverings and conduit, you want to lay it across the floor. So if you lay it across the floor, it might sustain damage. So I actually had a lady where I worked at previously. She had the cable under, and I think she put her feet up on the wall, and every once in a while she'd unplug herself. I figured that one out real quick. But the other thing is she'd kick the cable out, and it would end up under her rolling chair, and she rolled over it so much that she frayed the cable, and she couldn't get online because she's like, it's plugged in. And then I went in and I said, that's your cable? And she goes, yeah. And I said, do you notice the problem? Oh, no, And I said, that shouldn't be exposed. So it had broken open and wasn't exposed. So that's just one of the issues that you want to think about. Electromagnetic interference. So you want to make sure your cabling is away from fluorescent lights and any big electrical motors. So you don't want to have it next to electrical activity. I did, every year when I worked for my previous high school, it was great. We used to be able to totally rip apart our room and rewire it. It was a great activity for students. And one year, one student's like, I can't, I'm having problems. It's intermittent. I can't get online. And then we double checked to see what was going on, and somebody was lazy and just ran right over the fluorescent lights, just ran his cable, just that one cable. Luckily, it was just the one. Ran that one cable right over the fluorescent lights, and he was having issues. It caused noise. And then anytime you're in the building, so anytime you have it's above ceiling tile or it's in the subfloor, you want to make sure it's plenum rated, it's fire rated. So there's certain codes that you want to follow on top of the EIA, TIA. So you want to make sure that we've got the fire rated cable. So it's actually coated with PVC, and it produces less smoke than regular cable that's coated with PVC, and then it's not as toxic when it burns. But you want to be careful. And then grounding, you just want to follow grounding requirements, follow them. You want to make sure you have some slack. So sometimes you see at the end of cable runs where they're looped, that's your extra, because you don't want to have just enough. You don't want to have to run anymore again. So you want to be able to, just in case things change or you need a little more cabling, you just want to make sure you have a little bit of slack. And then cable trays, brackets, braided sleeping furniture grommet. You just don't want to overfill any of that stuff. So overfilling things is just like squeezing them too tight or bending them in half. So you just don't want to do any of that. So think about the hose example. If you bend a hose in half, a water hose, your water's not coming out. If you squeeze the hose too tight, it's going to have less water coming out. So you just want to think of things that way. Patch panels. Patch panels is just a way to organize the cabling coming in. Patch panel does nothing other than plug into the system, and then it'll plug into a switch. So, that's what we'll do. And then follow any standards or inventory procedures set by the company you work for. And then document. Just in case you need to look at that information later. If you document everything, it's going to make your life easier later. Because if it looks like this and it looks so pretty and everything has a purpose, and I'm not saying we're going to be able to do it this way all the time, because sometimes we're extremely busy in IT. But when you have it done like this, it makes your job easier the next time you come around. And then each one of these will have a purpose. It would also be labeled here probably as well. And then monitoring the environment and security. So you always want to make sure that everything is safe. You want it physically secure. So for example, the IT department, I think I've probably said this before, but the IT department at Rock Valley College, they have a doorbell that you ring to get in. So not only do you ring to get into the IT department, you are then, once you're in, you talk to Heather, and then she will get you where you need to go if you have a meeting or if you're supposed to talk to somebody. But you cannot then get into the server, the data center. So there's a locked door to get into IT, and then there's a locked door to get into the data center. So that one's pretty secure. There's a place called Northern Trust, and that is in Rochelle, Illinois, that I took a tour of. And that place has some physical security that is top notch. They have. So you just want to make sure that your important information is safe. And then that it's not going to have any issues like heating and ventilation issues, air conditioning. So you want to have your HVAC set up and managed in a way that will keep everything cool. Might be a little cooler in the data center than it is everywhere else, but those devices produce a lot of heat. So you want to make sure that you keep that going. And then you'll have some environmental monitoring that you might have going on that monitors all of the conditions as what you need. So you don't want to be too humid. You want the temperature at a right degrees. You want the humidity to be right. You don't want it too too damp in there, and then you want all of the airflow to flow through correctly. So you'll have sensors, HVAC sensors, and industrial control systems, and any supervisory control and data acquisition. So you'll have any of that equipment. So you'll have all these alarms. I taught with a gentleman a couple summers ago, and he was, he was the chief information officer for either the state of Virginia or North Carolina, or one of those states over there. So they had a hurricane come through, because that's what happens, right? So they had a hurricane come through, and all of their data center was in the basement. So their data center was in the basement, and the hurricane came through, and all of their equipment was underwater. And up until then, everything was fine, but now it was a whole bunch of water. And you can't just run into a basement full of electrical equipment and just bring it right out. So they had to be really careful about moving everything out. But they also had to get that stuff back up and running in no time. So luckily they had a monitoring system that gave them an alarm, and it wasn't too bad. But really, in a hurricane, it's not like there's anything you can do. So they had to wait and then get everything upstairs. So security is vital, and so is the protecting from the elements and like temperature and humidity, things like that. So you got many different things that you're going to think about for that. And that is everything for chapter 2.1. So we went through demarcation to workstation, cabling, monitoring. So in this video, it was just cabling and monitoring. And in the next video, we'll go over network documentation.